Rapid test case modeling, a complete solution to automatically creating models from tester activity. So let's start by thinking about traditional software testing. Most testing in organizations is still a manual process. Most have experimented, but the reality is there's still very little to no automation taking place. It's a random process. Often there's no science behind the test case design and the choices over what and how a component is being tested. It's unstructured. Usually there's lots of ambiguous textual data stored across many systems. There's a lot of repetition across tests covering the same functionality with small variations on the same theme. It's not thorough enough in terms of the level of functional coverage, what's being tested and how effectively. Predominantly, that's because there's no way to measure the functional coverage. It's virtually impossible to keep up with the rate of change pace, which is amplified by the introduction of agile development. We have to create, update, and execute tests inside each sprint whenever a change request is made. Generally, the whole process is too slow because there's just so much manual activity to undertake all the time. So what is VIP and how does it help? VIP is a complete and customizable testing framework that has 5 major components. The first is Test Modeler, a SaaS-based BPMN tool to model processes. It will automatically identify the optimum set of test cases using advanced coverage techniques, and it can directly support model-based test design or behavior-driven development. At its heart is a powerful TDM engine that lets you make sure you have the right data in the right place at the right time to support your automation. Everything can be defined using Excel, reducing the time learning new tools and letting you reuse your existing test assets. The framework has direct support for Selenium and Appium, plus it can connect to any API. It lets you use your own homegrown test framework, as well as supporting the major automation tools such as Eggplant Functional, Parasoft, and Perfecto. We can virtualize endpoints and build intelligent and matching request-response pairs, spin up sandboxes on demand, as well as supporting all message types. Finally, we can integrate with your DevOps toolchain and help you integrate your software lifecycle so you can build up an accurate map of dependencies and start moving into the world of AI-driven development. All the components roll up under a DevOps framework. That is in fact a full RPA solution. It helps you build up an integrated software lifecycle framework. For example, you can join your Git check-ins to your Jira repository, to your test data, to your expected and actual results to achieve full end-to-end traceability. So you can get started with our recorder, which you turn on in the background and it captures tester activity. This automatically builds models from either existing manual test cases. It can be embedded inside automation scripts or turned on to listen during exploratory testing. Once we've captured the tests, we can then explore the resulting test cases inside Test Modeler to create an audit of the test cases where we can measure the functional coverage of our existing assets. Automated models are imported into Modeler to enhance the functional level of the application tested and deduplicate tests to reduce the number of tests being executed. Automated tests are exported for execution as part of the continuous delivery ecosystem. No scripting or technical skill is required. Anyone can get started from any background. Mathematical algorithms are used to create coverage-focused tests. If the application changes, the model just needs to be updated to repair the associated automation tests. This is necessary for agile development. So, onto the demo where we will record some manual tests, review the activity, and create some automated models for execution. There's a lot in the VIP framework. However, this demo will focus on 3 of the components: the modeler to record and automatically create automated models, the TDM engine to define data rules, and the automation framework where we'll be mapping our recordings for execution in Selenium. I've broken the demo up into 6 parts so you can skip through to the bits you're interested in. Part 1 of the demo is to record some manual tester activity. Now in the top right hand corner of the browser here, you'll see our extension. This sits in the background and listens to activity as we're interacting and testing the system. So we're going to start a new recording here by clicking the start button. And we're going to go through to the login page. And in this scenario, we're going to enter an invalid email and an invalid password as our test. So we're going to enter an email of an exclamation mark, and we'll leave the password field blank. Now we're going to click sign in, and we'll see 2 error messages come up. We're going to end the recording and we're going to upload this into the test modeler platform. Now here we are inside Modeler, our SaaS-based platform. What we have here is a view of all of the journeys that have been recorded in our system. You'll see down the bottom here, our invalid login and invalid password journey has been registered. So let's go in and take a look at what activity was recorded. Now what we can see here is the activity that's been recorded. So you'll see that we started at the base URL, we clicked the link sign in, and then we entered the various fields. Now what you can also see is we've recorded a wide array of data for each of the actions. So we can see here we've recorded page references, an English translation, some object identifiers, along with some code. We've also logged the various state, so the underlying HTML document, the underlying DOM. And we've also recorded some nice images which show us the transition between the test scenarios. We've also captured console logs, if there were any console errors that appeared during the execution, along with capturing any API traffic that was a result of the execution. Along with the journey we recorded, there was also a number of other tests that were recorded and uploaded. What we can do is go into the blueprint view, which provides us with an overview of what has been tested and how effectively. So at the topmost view, we get a page map of all of the page structures that were visited in that session. If we expand one of these, like the login screen, what we can see is all of the elements that were interacted with. So we can see here there was a number of tests that passed through the email address field. If we click on that field, we can see some metadata about that object. But also we can go in here and see the various data values that were entered for the email address. Similarly, if we click on the password field, we can see the various values entered for the password. We can also view the underlying journeys that were traced back through this field. Now this represents a global view of all of the activity that was undertaken and tested in the application. We can go in and apply filters to see what parts of the application were tested by different testers. So here we'll select Hugh and let's see what he's tested in the application. So we can see Hugh mostly tested adding various products to the checkout cart. Let's explore another user. So here we've selected to explore James's activity. And what we can see here is James mostly focused on the login screen. And if we can expand that, we can see the journeys and routes that he tested through the application. What we can also do is inspect our heat map view. This represents true functional coverage overlaid on top of the user interface. Here we can see we've interacted with the email field, the password field, and also the sign-in button. None of the other elements on this screen were interacted with. If we click on the email input here, we can see there were 8 test cases that passed through this field. We can go through and inspect the functional coverage for the other screens. This gives us a nice overview of what's been tested and how many times it's been tested, so we can start to understand if there's any over-testing or under-testing occurring in our test suite. Now we have some recorded test activity. We're going to import that activity into Test Modeler, where we'll start to explore additional edge cases and generate coverage-focused tests along with test automation. So we're going to go to the Connectors tab up the top here, and we're going to select to import our recording. Now we're going to focus on the login screen, so we're going to select this page here and we're going to click Import Automation. So here's our model that has been imported from the recorder. We can see we start off at the start URL, we click the sign-in link, we enter our email addresses, we then enter the passwords and we click the button Sign In. This has all been automatically created from our recordings. What we also have here is the test data that has been defined on each of the inputs. And we also have the automation that has been overlaid on top here and tagged using our keyword-driven framework. So you'll see we have the actions, which correspond to Selenium automation actions. We have the identifiers that have been picked up, and we also have the test data tagged against it. So what we're going to do now is add in a new type of email and password, which is going to be too long for the validation. So we're going to call this email too long, and we'll add another block over here, which is password too long. And we'll connect this up to our model. As so. Now what we're going to do is go in and apply some test data using the TDM engine. So we'll add a new variable reference here, and we're going to reference our email address field. So here we have our data editor window, and this contains a vast array of over 500 synthetic data generation functions. Here what we're going to do is use our random string fixed length function. And what we're going to do is use this to generate a string which is 50 characters long, includes special characters and numbers. And we're going to assign this to the email field. And we're going to do the same again in the password field. So we'll go in here and we'll use this same function to generate a password which is over that validation threshold. And we'll click Save to assign. Okay, so now we've added some new data blocks here to test the email and password length being too long. We're going to go in and generate some test cases. Now, the way we generate tests is we create coverage profiles. Here we want to test our model exhaustively, so we're going to select the exhaustive coverage profile. We'll hit Save, and then we're going to generate some tests. And this has come back with 12 tests. So let's take a look at them. We'll go into the test window here, and we can see the 12 tests that have been generated, and we can flick through these to see the different combinations that have come out. Now what we're going to do is export these tests to execute them inside the VIP automation framework. So here we have the files that the VIP automation framework ingests to execute that automation. So let's take a look at the module and also the data template. So our data template has all of the data that we need to execute the automation. At this point we can come in and we can start to enter additional synthetic data generation functions, or we could go into the backend database and pull in data if we need to. We also have our module file which contains all of our keywords that we're calling during the automation execution. So now we've embedded our automation in the VIP framework. Let's run the automation using our command. Simply, we would have this embedded in our continuous integration system. Now our automation is executed, if we go back into Test Modeler, we can review the automation execution results. So here we have our dashboard display that gives us a summary of all of the tests that were passed and failed during the date range specified, as well as the number of tests that have been executed on each day. If we scroll down here, we can see the underlying automation results. So here we'll see an array of models which have been executed. And we can see at the top here our recorded model, where we've had 12 passes and 0 failures. If we dive deeper into this and open up the model, and we go into our test view, what we can see is the automation results tagged against each test case running through the model. If we had failures in here, we could start to interrogate those failures to try and understand where that is failing in the model. We can also go back in here so we could select a specific test case, and we can view the historical results for this specific test execution. So we'll see here at a previous point in time we had 2 failures and then we had a pass result. In this demo you've seen how we can rapidly create models for rigorous test case design. Our recorder is a powerful accelerator for model-based testing. Anyone can use it from any background. You can audit and reuse existing test artifacts, and you can easily create coverage-focused automated tests. This allows you to save time by quickly recording tests instead of manually coding or writing manual tests by hand. You can rapidly update your tests every time a requirement changes. You just need to update the model and then the automated tests get updated as a result. You can deduplicate your tests and then optimize them to get the minimum number of tests which cover the maximum amount of your application. This increases quality by using mathematics to create your tests which are coverage driven, increasing the quality and variations of test data being applied inside your test scenarios, and also by tracking exactly what features you're testing so we can pinpoint failures back to the model and start to understand what went wrong and why. Feel free to get in touch if you want a trial or you would like to discuss how we could help build a more robust automation framework.